Good day. This group is named Ramdhanie'D'Wet, and our project title is Rainfall Prediction Using a Regression and ARIMA Hybrid Model. The prediction. What is the importance of prediction? Well, first of all, it allows nations, countries, or even unions such as the European Union, CARICOM, to strategically plan, have nationwide or group-wide planning. You could have disaster reduction, sustainable use of natural resources, etc. Rainfall is influenced by many different factors, mainly atmospheric factors, such as temperature, sea level pressures, humidity, etc. In this slide, we'll call those independent variables. Now, scatterplot could show how these various factors relate to each other, and we are using multiple linear regression as well as ARIMA, which is we're using as data mining to get the information and develop our model. The aim of this paper altogether is to combine both MLR and ARIMA to predict the 2 years, to have a 2-year prediction. Now, multiple regression, linear regression, this is the model that we generally use here, where Y would represent the dependent variable, and X and all the other values on the right hand side, which would be beta and X and epsilon, would represent the independent variables, where beta would represent the probabilistic component model, and it would also determine the contribution of each of the independent variables, which would be represented here as xi, and we would also try to keep the error epsilon as small as possible. So the general steps involved would be, first of all, to examine the data for linearity, to fit the model using t-tests and f-tests, which we would use with stepwise regression. We would validate the assumptions of MLR using graphical methods, and we would evaluate the fitted using the R-squared model. Now this slide here would show on the bottom section of the slide, bottom left hand, you would recognize that there would be representations of all the variables in the slides. So from this, you could see that there is a maximum temperature. The maximum temperature and the sea level pressure has a low correlation. The minimum temperature and the wind speed have a moderate correlation. However, we could see that there's a very strong correlation between the humidity and the rainfall. And again, there's a moderate correlation between the humidity and the sea level pressures. Now, this here is what we would actually get when we do the regression. In this case, as we said, the rainfall would represent the precipitation, PRCP, and everything else would represent all the other factors, all the other dependent factors on the other side. Now, I'll hand you over to Suresh.
Thank you, Kester. Good day, everyone. So, for our mathematical model, we need to assume certain assumptions. They have to be made, right? So, those assumptions are that the data is normally distributed. And the other assumption is that the correlation between the residual and fitted values. Now, if you watch the histogram, we can see that the shape of the slope can be resembles a normal slope. And on the graph on the top right, we can see that's where the standardized residual versus the fitted values, we can see the correlation. Now, for the next slide, the ARIMA. Now, ARIMA stands for Autoregressive Integrated Moving Average, where the models can relate to present values of a series to past values or past predictions or errors. So the ARIMA model can be written as ARIMA with PDQs, where these PDQs are variables. These variables are used to help with the model fitting, and they are edited so that they help to match the required data set. Now, ARIMA model development. The general steps involved are to visualize the data, which is identifying any seasonality or trend in the time series plot to determine if differentiating is necessary. Differencing is necessary. My God. Examine ACF and PACF plots to obtain possible terms for the model by observing lag spikes. Build and evaluate the model using the modified box Bayes or Young test. The plot of residuals versus fits and the ACF plot of residual are also examined to validate the model. Now examining the time series data. Seasonality is observed from the time series for the maximum temp, the minimum temp, and the humidity and rainfall. Time series for minimum temperature showed an upward trend indicating that the difference of lag 1 should be used in the model. For the other variables, there is no trend observed or, if any, it is little. Now, the time series plot of actual predicted rainfall. Now this diagram shows the time series plot for the max temp, the minimum temp, the humidity, and the precipitation, where the red line symbolizes the predicted values and the blue line symbolizes the actual values. Now the ARIMA model results. The ARIMA model for the predictors are reduced for the regression model are basically divided for the max temperature, min temperature, humidity, and precipitation. Therefore, there are different values for the PDQs. Now, the box test below shows that all the values are above 0.05, which indicates that the residuals are independently distributed from each other. I'll now hand you over to Shivan.
Thanks, Suresh. Now, a RIMA prediction for the next 2 years. So, from the time series plot for the next 2 years is shown, and these values would be used in the regression model. So, A is max temperature, B is min temperature, C is humidity, and D is precipitation. And the red portion of those lines for the graph are the predicted values for the next 2 years. A RIMA model verification. So, for each of the variables, we could see that there is a constant variance from these plots, and that means that these plots are acceptable. The ACF plot versus residuals, we could see that these are also acceptable because there are no large spikes outside of those red lines, which is the non-significant zone. This also implies that these variables are independently distributed, and still for the same order: max, min, humidity, and precipitation. Hybrid model results. Uses the prediction from the ARIMA models. So the values we got from those actual predictions from the ARIMA models were going to be used inside the regression equation. And from the plot, you could see that the purple line is the hybrid fit model, and that shows the least deviation from compared to all the other plots we have there. As you see, you have large green and blue spikes from other models, while the purple has the least random spikes. Hybrid model accuracy. Time series plot shows that the hybrid model is closest to the original values, and the green symbols indicate the hybrid plot, and you can see that there is the least amount of scatter on that plot for the green symbol, so meaning the hybrid plot has the highest accuracy. And prediction for the next 2 years, we plotted the hybrid using the hybrid model, where the blue line on the plot is the actual predictions, the red line is the upper limit for the prediction, the lower limit for the prediction, and the green line is the upper limit for the prediction. Now I will pass you over to Kester for conclusion.
Thank you, Ramdhanie. And for the conclusion, we would recognize from the results that we have there that the The predictors account for 62% of the variability in relation to rainfall. Also, our hybrid model allowed us to get a 2-year prediction. The hybrid of the MLR and the ARIMA developed a more accurate model than the other models, such as MLR by itself or ARIMA by itself. And also, the 2-year predictions that we developed would allow stakeholders such as farmers, government, conglomerates such as CARICOM or EU to be able to plan in the future, to plan in advance for any events that may come in the future. Here we could see listed our references, and thank you very much for listening to our presentation.